Welcome to Digital VLSI Design Virtual Lab, experiment number 1, MOSFET characteristics. The aim of this experiment is to plot the output characteristics and the transfer characteristics of an N-channel and P-channel MOSFET. To proceed for the simulation experiment, click on the Simulator tab. In this new page, 4 links can be seen, 2 for NMOS transistor characteristics and 2 for PMOS transistor characteristics. In order to perform the output characteristics of an NMOS transistor using ngSpice, click on the first link. Once we click on this link, a login page will appear where the user should enter his login name and the corresponding password. If you have not yet signed up, you can do so in this link provided. In this new page, you have the interface for performing the experiment. On the top of this page, you have the schematic diagram of the setup. On the left bottom, you have the ngSpice program codes, and on the bottom right, you have a space for plotting the output characteristics. If you look at the ngSpice program, the first 2 lines defines the voltage sources required to set up this output characteristics experiment. VDS corresponds to the voltage source supplied between node 1 and 0 as defined in the first line. VGS corresponds to the voltage source given between node 2 and 0 as defined in the second line of the program. The third line corresponds to the NMOS device in the setup, which is labeled as M1 with its terminal drain connected to node 1, gate connected to node 2, source and bulk terminals connected to node 0. One can also define the length of the device and the width of the device as shown here as 0.18 micrometer and 0.36 micrometer respectively. In the fourth line, you have a command for DC analysis, wherein the voltage source VDS is varied from 0 to 1.8 volts in steps of 0.1, and VGS voltage source is varied from 0 to 1.8 in steps of 0.6. This corresponds to 4 different output characteristics corresponding to 4 different values of VGS. The remaining part of the program consists of SPICE model level 49 for an NMOS device, which involves various parameters as shown here, which the user should not vary. And the program ends with a .end command and a run command. In order to perform the simulation, click on the Simulate tab. It will take a while for the output characteristic curves to appear on the right bottom of the page. The x-axis of the curve corresponds to VDS values, and the y-axis corresponds to corresponding drain current ID. 4 characteristics curves are seen in this graph corresponding to 4 different values of VGS. The bottom one coincides with the x-axis, which is for VGS is equal to 0 volt. The second one corresponds to VGS is equal to 0.6 volt, and the third one corresponds to VGS is equal to 1.2 volt, and finally the fourth curves corresponding to VGS is equal to 1.8 volt. One can repeat this experiment after varying the value of VDS values or VGS values, and one has also the privilege to vary the length and width of the device to any value greater than what is already given here. In the same manner, one can go back to the Simulator tab and choose the appropriate links for transfer characteristics of NMOS device, output characteristics of PMOS device, and transfer characteristics of PMOS device. Thank you.